Today's lesson is a continuation of our study of Lewis dot, Lewis structure, and structural formulas. But as you can see on the screen, I have something a little bit different here. I have three elements, but they are not neutral. They are ions. I have the chloride ion, the sodium ion, and the sulfide ion. I can still do Lewis dots for ions, but now I'm going to have to remember, what does this mean? What does this mean? What does this mean? It means that the number of electrons are different than what you would find for a neutral atom. So let's start with neutral chloride, and then we're going to change it to be the chloride ion. So we've already done the neutral ion, not the neutral ion, the neutral atom. And we know it is in the seventh group, so it should have 7 electrons. So I'm going to put 7 electrons around here. So 1, 2, 3, 4, 5, 6, 7. So I have 7 electrons around chloride, but that would be the neutral chlorine atom. But this is the chloride ion. So this minus sign means that it has 1 extra electron. So where am I going to put that extra electron? Well, I think you can see that this electron right here doesn't have a partner. So I am going to put the next electron here, and then that is the chloride ion. But it's charged, so I still have to say that. So I'm going to still put the minus, and I'm going to put this in brackets to kind of show that's a little different. So there is the chloride ion. And once again, I still end up with 8 electrons around the atom, and that is the stable chloride ion. All right? So what about sodium? Sodium is in the first column. So I give it 1 valence electron. But according to this, it has a positive charge, so it loses 1 electron. So I lose this electron, so I'm going to have to get rid of this electron, right? So where did it lose that electron? Well, if it got next to the chloride could have stolen its electron. So once again, I have to put positive, and I could put this in brackets to say this is a Lewis dot for that. But notice there are no more dots around the sodium because I've taken away its valence electron, and now it's positively charged. All right. So what about our last example, sulfur? So I have sulfur, and normally for a sulfur atom, I have 6 electrons because it's in the 6th group. 1, 2, 3, 4, 5, 6. But sulfur forms a -2 ion, the sulfide ion, so it gets 2 more electrons. So I get to add 2 more electrons, 1 here and 1 here. And now this is the sulfide ion, but I can't leave it like that. So I'm going to put it in brackets and say that this has a 2- charge. So this is how I draw Lewis dots for ions, the chloride ion, the sodium ion, and the sulfide ion. Now let's look at some polyatomic ions and also another compound which has something a little bit unusual about that. So let's start with the hypochlorite ion, and I draw that like I did other molecules, except I have to remember that here I have a minus charge, so I'm going to have to add 1 extra electron when I'm making this a Lewis dot. So I'm going to start with, well, I can start with either chlorine or oxygen because there is no middle when you just have 2 atoms, so it doesn't matter which one you start with. So I'm going to start with the chlorine. Okay, and it, as you remember, is a halogen, so you should have 7 electrons. So 1, 2, 3, 4, 5, 6, 7. So it can bond right here, and that's where I'm going to put the oxygen. So I'm going to put the oxygen, well, let's do a different color. So I'm going to do the oxygen, so I'm going to put that here. And I have 1, 2, 3, 4, 5, 6, because oxygen has 6 electrons. But I'm not done, and you can tell I'm not done because here I've got a lone electron, and I also didn't add this extra electron here. So I have to add 1 electron to this configuration, and I bet you can figure out where that one electron goes. It's going to go right next to this lone pair. So I have another electron there. And now I have 8 electrons around the chlorine, 2, 4, 6, 8, and 8 electrons around the oxygen, 2, 4, 6, 8. So this is correct, but I really should tell everybody that I drew an ion. So I'm going to put brackets around it. Oops. Brackets around it and give it a minus charge. All right? So there is the Lewis dot for the hypochlorite ion. You could also do Lewis structure and structural. So if I was just doing the Lewis structure, I would erase these in the middle. Oops, I kind of lost a little bit of my chlorine, so I'm going to put that back in. Let's put the L back in. Oop, now it's in pink, but that's okay. And I'm going to erase this right there. And instead of that, I'm going to put a line here. So I'm getting used to this whiteboard here. So there, instead of the, oops. See how fun doing these new technologies. So there we have it in Lewis structure. I just replaced the pair of electrons with a line in the middle. And now if you wanted to do structural, I don't know if I can erase these that good, but let me try it. So I'd erase all the electrons on the outside, but I can't seem to do this without erasing the names also. So maybe I'll just start from scratch, and it would be just ClO minus. There we have our Lewis structure and our structural formulas. All right, let's move on to BF3. So what is unusual about that? Well, let's start in a different color again. Let's do this one here. So I'm going to put boron in the middle. Why do I put boron in the middle? Because it will make 3 bonds. It has 3 electrons. 1, 2, 3 electrons, valence electrons. It's in group 3. And I have 3 fluorines, so it will bond in each of those spots. So I'm going to put a fluorine here. It has 7 electrons. 1, 2, 3, 4, 5, 6, 7. A fluorine goes down here. I'm going to bond it here. 1, 2, 3, 4, 5, 6, 7. And a fluorine here. And I'm going to bond it 1, 2, 3, 4, 5, 6, 7. So when I do my check at the end, I notice that I have no lone pairs. That's good. And I have 8 electrons around each of the fluorines. But there's only 6 electrons around the boron. Well, if you remember from the previous video, that is okay. It is in group 3. Group 3 will only end up with 6 electrons. So this is actually the correct formula for boron trifluoride. And boron trifluoride is a way we name inorganic compounds that we'll also learn about later. So there we have ions and some unusual covalently bonded compounds. And that's it for today. So thanks for listening.